Hi, Verge. Welcome, everyone. Monday. I'm Mark. I'm in blue navy with horizontal stripes.
And I'm Verge, and I'm also in Navy with horizontal stripes. This was completely unplanned, but this apparently is what happens when you start working together, even when it's virtual. So I'm from Lafayette High School in Oxford, Mississippi. And Mark, you are from?
Ryan High School in Denton, Texas.
And I'm sitting here in Mississippi, just like Mark is sitting in Texas.
Yeah, and we are getting more streamlined as we knock a week off. Huh? This week, we're going to talk about Unit 8. We're going to talk about the exam in a bit. And Unit 8 is not on the exam, so you'll notice we say we're tying it back to previous units. So we're starting our integrated review for you, which will then continue on through May 1st. And my slide doesn't want to advance. There we
go. Okay, so we went over this on Friday. It was really brand new news on Friday, but just to recall, our exam is going to be on May 12th. That's a date change, and it's online, which we already knew. Only free response questions, and only 2 of them. One will be 25 minutes, followed by 5 minutes to lock it in and upload it. And then the second one, 15 minutes, followed by that 5-minute time to lock it in and upload it. Units are going to be for AB, units 1 through 7 in the course exam description. And you're going to be most likely testing at home, although maybe you might be testing at school. In any case, it'll be open note, open book, and calculator permitted. Anything else, Mark?
I think that's it, although I almost decided to live edit the slide, but figured that'd be a lag issue, but it really should see 45-ish minutes. We need to talk to the
we
arithmetic.
can do that for tomorrow. Yeah, right. We can do that for tomorrow.
And we're at 4 days.
I can't, this is unbelievable to me that we actually are without a mathematical error or a verbal mistake or anything like that for 4 class days. And if you add the weekend in, that's really 6, you know, so that's pretty good.
Well, I made an algebra 2 video Saturday that I made a mistake and I caught it. So I don't know if you catch those, if you catch them, but. All right, so we've done our introductions and our lack of corrections. We're going to spend about 5 minutes on a warm up here in a minute. It is not from any of last week's material. We're actually using it as a lead into chapter 8 or unit 8, sorry. And we're going to talk about the average value of a function on an interval today. But what you're going to find is there's a lot of fundamental theory of calculus and definite integrals here. We're finding a lot of practice at antiderivatives and plugging in bounds and subtracting. And we'll work guided practice in with that. And then we'll wrap up. And I did not get a chance to get stuff in the Dropbox this morning. I'm sorry about that. We had a faculty meeting from my own school, and I will get that online before 3 Eastern. I know some of you like to print ahead of time, and I apologize.
But if you're not watching live, you can absolutely print that stuff or look at it and then be able to follow along later in the day or tomorrow or whenever.
Excellent point. Mm-hmm. All right, so here's our warm-up. And this is not calculator active.
No calculator. Okay, so if everyone could figure out the definite integral from 1 to 25 of the square root of x dx, we're going to give you about 40 seconds. If you are not watching live, of course, you can pause the video. And in this interim, I am going to tell a joke.
Oh, I look forward to these.
This is a good one. It's especially a good one if you don't get it, because you should look it up. Anyone who's high-level math should get this joke. Why did the chicken cross the Mobius strip?
Why did the chicken cross the Mobius strip?
To get to the same side.
I see what you did with a twist there.
Okay, maybe we'll have a live action Mobius strip kind of a thing one of these days. So just to make sure you know what a Mobius strip is. It's actually in a branch of math called topology, which some of you might end up studying some point. Some of you probably already have. All right, Mark, do you want to go ahead and show us how you did this warm up?
Yes. All right. So new share to my camera. So this is the original problem, that integral from 1 to 25 of the square root of x dx. And the first thing I do normally, I would just copy it down immediately as x to the 1/2, at least mentally, if not with pencil and paper. And then this is our review, right? How do we find the antiderivative of x to the 1/2? We've been doing some power rule with indefinite integrals already. So I add 1, get 3/2. Dividing by 3/2, same as multiplying by 2/3. And we're evaluating that from 1 to 25. So I plug in my upper bound of 25 and I plug in my lower bound of 1 and I subtract 25 to the 3/2. Since this is non-calculator, you could do 25 cubed off the bat, but it's a lot easier to do the square root first. So square root of 25 is 5, cube it, and I get 125 times 2. The 1 is a much easier game since that's just going to be 1. And I end up with 250 thirds minus 2/3 for 248 thirds.
That's what I got. And
what
248 is not divisible by 3, right?
What does that end up being? 82 2/3 if you're going mixed number, but not necessarily.
Yep, that's correct. Yep.
All right. So back to our slideshow.
Actually, you're going to want to hold on to that for a little bit because that's going to become one of our examples when we extend the idea. So just saying.
All right, thanks.
Mm-hmm.
Oh, that was for them. I'm sorry.
Oh, yeah.
I'm playing. So before we get into the guided practice, I actually made a video. Not gonna let the BC guys have all the fun. I made this video on was it, I guess, Saturday afternoon.
Well, today is Monday.
Yeah,
and
I know.
Yesterday was Sunday.
So I was looking at, so I have this curve that's this blue stripe here, and I've made this highly scientific and extremely accurate model of this function by putting strawberry milk mixture into a pitcher. And if I could get the video to run, I think I have to go to my pointer. Oh, not even. Right. Are we live yet? Oh, man.
It's okay. Oh, here it goes. I think it's going.
There's motion. Yeah, there we go. So what we're doing is we're trying to find the average value of a function. So it's shaking down. There it goes. Okay. And so, and I'm pounding on it. I'll skip ahead to the end here. And I believe I'm writing, I drew my line on there. So what we're seeing, whoa, back. All right. So here was our original curve that measured the volume of, or at least a cross section of the volume, shook it down, and now our cross section's here. And what I suspect is that that's the average value of the function. And we want to figure out how to do that with calculus because we can't always make these highly scientific models. So I did my best to draw that original curve, try to make it the equivalent lumpiness. And we're going to try and find the area under there. And Vert, remind me, how do we find this area between the x-axis and f of x?
You would set up a definite integral, the integral from a to b of f of x dx. That's going to give you the area between the curve and the x-axis. In this case, that result should be positive since everything's above the x-axis there.
Wow, that was a very thorough answer. Thank you.
Yeah, I already saw these slides about 4 hours ago.
So we shook the sand down and we ended it with something that was more rectangular, and we got this much easier function to play with, which is just y equals k. And so I know the width of this area, so I can find k pretty easily. So I can just divide that area by the width, and I find this average of f of x on the closed interval from a to b, because it's the height of a rectangle that would have the same area.
I think that's key. The average value is the height of the rectangle that would have the same area. And it also has the same base. So the notice how the base is b minus a in both cases. And then the height is that k value for the rectangle.
And if this were actually a linear function and you were playing with trapezoids, you could actually see that relationship as well in trapezoid formulas because we use the averages and things like that.
Mm-hmm.
So, Verge, Does this look familiar to you?
It is. This is my, according to my iPhone, this is my average number of steps for an entire month. And I think about this kind of stuff all the time, because if I just walk for one day, how does it affect that monthly average? Well, you have to walk a lot in one day to affect that average, because there's 30 days that you're really dividing by there. But on average, it's saying that I'm walking 10,315 steps if I would do the same exact thing every day, which I obviously don't. And that's where that line came in. Mark, can you do that again? Draw the line again. Zoop. That's awesome. So that line is roughly at 10,315 steps. And that would be if I were some sort of a robot walking the exact same amount every single day.
And just like your teachers, I'm sure they do this too, and you may even have started doing it. You start reading articles in the paper, or you just see things, and you start realizing when people start talking about rates and functions and areas, and you realize there's calculus kind of all over the place. So here's another place.
So this one, many of the students out there probably don't pay any sort of utility bill, but someone in your family probably does. And depending on your locale, you can sign up for average monthly billing. So for example, in the South, our electric bill is very high. Guess when? In the summer, right? Because we need the air conditioning. But if you can't afford that high bill in the summer because you kind of have a very fixed income coming in each month, you can talk to your utility company and they will average out your bills, and they will say, okay, well, you just pay $80 a month or $60 a month every month, kind of like you might do for rent for your apartment or something. And then we'll be good, because overall you'll have your right amount. And that's the average value. That is it.
And this one's neat because it's actually the inverse of the situation you just talked about, right? Because it's higher in the winter here. So
that looks like a heating bill.
This would be like a
Northeast.
southern heating bill. Yeah.
Yep. Totally. Yeah, we actually do need to turn on our heat where I live. People don't even believe me, but it's true.
And this one has a vertical shift of 1/12 of your deferred balance as well, if you really want to have fun with it.
Yeah. So that's actually my picture that I took a long time ago, I think, Mark, isn't it?
I stole both of those from you. Yes.
Yeah. Okay. This is important to take a screenshot of. Go ahead, Mark.
All right. So just to formalize what we were talking about on those pictures, the average value of a continuous function f over an interval a to b, closed interval, is 1 over b minus a times the integral from a to b of f of x dx. Now that 1 over b minus a is actually the division by b minus a lot like I divided by divided by 3/2 by multiplying by 2/3 on our warm-up. So you can use either one of these formulas. Obviously, they are the same. That division can even go inside the integrand since it is a constant. Do you want to talk about it? This is a continuous function, but in our course, you will find notes, and this came up between version is in a discussion, that it actually can be extended over non-continuous intervals, but not in our course, fortunately. But
and the kind of continuity or discontinuity is very important in that case. Yeah. And so, yeah. So this is a.
So we'll save that for your Cal 2 and Cal 3.
Yeah.
So how can this apply to the warm-up?
Well, let's say that instead of just being asked to find the definite integral, the integral from 1 to 25 of the square root of x dx, what if instead we were asked to find the average value of f of x equal root x on the interval from 1 to 25? So that's really going to be our first example in our notes. So I'm going to go ahead and grab the screen. Is that okay, Mark?
Please do.
Okay. So AP Live number 9, 8.1 average value. Today is Monday. Yes. Ever since I started doing.
Monday's an afterthought because it's the one day that's easy to remember.
Yeah. Since I started doing this, though, I've been really good at knowing what day it is. I think I do this the night before, and it seems to work for me. I guess I dream about it and I wake up knowing what day it is. Okay, goodbye. All right, so here's the problem written out in my highly technical font. And notice how all I need to do here by definition is take our result of our definite integral right here and go ahead and multiply by the reciprocal of b minus a. My b is 25 and my a is 1. So I'm going to multiply by 1 over 25 minus 1. So actually, when I did this problem, I did the exact same thing as Mark. And I'm just going to go ahead and slide in this 1/24 right here. So I'm taking this total area and I'm multiplying it all by 1/24. And the reason I'm showing this and not redoing it is that he and I did it a slightly different way here. I think we did anyway.
I kept my, I kept my 2/3 with my integrand and you put it outside, and that's fine.
And not only that, but like I was able to do then 125 minus 1 and get the 124. I don't know. I just thought it was.
And that's actually not an
little
integrand, it's the antiderivative, but yes, regardless.
Yeah. So then I have this 1 over 24. And then final result here is, I believe, 31 over 3. I actually cheated and used my calculator on it. Oh, I'm lying. It's 31 over 9. Okay, I wanted to just reduce that.
There should be a 9 left there, right?
Yep. Okay. So just, and I tend to be very visual. It's interesting. Mark and I are both kind of artists of sorts. He tends to do a lot of digital art, but a lot of hand-drawn stuff too. And I do a lot of like crafting type stuff, but I did do a lot of art in my youth. But here's my function, the square root of x, and then here's my area, which was that 24 divided by 3. And what I just found here, this 31 over 9 is
248
actually
divided by 3. Sorry.
Yes, this here is 248 divided by 3, but this 31 over 9 is this average height of the function. Average value is real average y value along that continuum. In math, whenever we see that word value, unless it's really specifically something else, it 99% of the time is the y value. So this is the average height of the function if I were to have a rectangle of the exact same area with 24 as the base.
And
so I'm just, go ahead, Mark.
I was going to say, if you tie it back to the FTC, remember fundamental theorem of calculus and this definite integral is taking that Riemann sum of every single infinitely thin rectangle in there and adding them up. So she is taking every single y value between 1 and 25, between 1 and 5 along the segment for x, 1 to 25, adding them up and dividing by how many there are. Of course, it's infinite, and that's why the calculus comes in, so we just divide by the width. But
right, as opposed to our examples with the steps and the monthly billing, those had a dividing by a 30 and a dividing by a 12. Well, with calculus, we're really being able to divide by, like Mark said, numbers that we're not normally allowed to divide by. Well, I'm just going to do 2 more examples, and then Mark's going to go ahead and do some more involved examples. The second one here is same idea, but just to practice with a different function, find the average value of y equals cosine of theta on the interval from 0 to pi over 2. And 0 to pi over 2, it looks a little different than this x equals 1 to x equals 25. Just wanted to do that. So what would I do? I would set up this 1 over b minus a, so 1 over pi over 2 minus 0 times the integral from 0 to pi over 2 of cosine theta d theta. 1 over pi over 2 minus 0 is going to be 1 over pi over 2, which ends up being 2 over pi cos.
Well said.
I have to think about antidifferentiating cosine of theta. So what could the original function have been? It could have been sine theta. The derivative of sine theta is cosine theta. And now we're going to evaluate that from 0 to pi over 2. So I have 2 over pi, and then times the sine of pi over 2 minus the sine of 0. There's your f of b minus f of a from fundamental theorem. So 2 over pi times the sine of pi over 2, which is 1, minus the sine of 0, which is 0. So final answer there, a little bit more abstract perhaps. We're not quite sure what 2 over pi means. About 2/3 is that average height on that particular interval for cosine theta.
I'm sorry, I've gone a little silent here. I'm actually trying to update the Dropbox. So
Oh,
fade out.
wow. If you fade out or if my screen goes gray, we'll know what's happening.
Exactly.
Okay. All right, third question. This one says find the average value of g of x, and this is another basic function, what I call just kind of basic functions. G of x equals 1 over x on the interval. These inequalities here. Another way to present that interval. Totally fine. A lot of times we see that for time, t equals time. But I would use that definition again. Average interval, average value is 1 over b minus a. So 1 over 3 minus 1 times the integral from b to a, in this case 1 to 3, of my function, which is g of x. So 1 over x dx. 1 over 3 minus 1 is going to be a half. And then here, my integrand is 1 over x. So I need to be thinking about, well, somebody took the derivative and 1 over x. Yeah, so anti-differentiate that 1 over x. You get natural log of the absolute value of x. And then we're going to evaluate it from x equals 1 to x equals 3. So we end up with a half times the natural log of the absolute value of 3, which is just natural log of 3, minus, I'm going to do this a little differently than my other two examples because you can, minus a half times the natural log of the absolute value of 1, which is going to be just 1. Make sure that you're making a little list off to the side somewhere, things like sine of pi over 2, and I just whip it off and say it's 1. Natural log of 1, I'm just going to whip it off and say it's 0. You know, those are all pre-calculus ideas, so make sure you know where that's coming from, and you might message your own teacher for a little review on that as well. So a half times 0 is a half, and then I have final answer, a half natural log of 3 as the average value. Okay, Mark. Oh, by the way, wait, don't grab the screen yet, Mark. I do want to say something. This was example 3. Check this out, Mark. You ready?
8, isn't it?
Yeah, so look. I'm making the 3 into an 8.
Example 3 of the live, example 8 of the worksheet. Nice.
Exactly. So in the Dropbox, there's a Mark will talk more about it, but there are 14 problems that deal with average value, and he's going to work several of them right now. But this actually is number 8, and it came straight off of AP Classroom.
And it was funny. I was in there disabling the comments on it after I uploaded it, and I know several of you have either paused us and come back or are doing it on the side like I was. But the number of G's up in the corner of guests looking at the document at the same time as I was entertaining. So I guess I will grab that screen back from you.
Okay.
And this is the document, and because I know some of you have already gone in there, some of you will go in there after the assignments, after we're done talking or whatever. There are 2 versions. It is the same document. So the 2 versions are this version, which you notice has a lot of space, and this is my, and this one is called 8.1 and 6.7 practice with space. And then there's another one that's called Paper Saver, which is a 3-page document. It has all the problems in 2 pages and the answers on a 3rd page. So if you're, like we are, we're not getting out and getting resources very often. If you're trying to save ink, trying to save paper, you can just print the first 2 pages if you want, or just open that up on your monitor and write the problems down since there's no space to write on it anyway.
Yeah, I only printed the Paper Saver version because I'm like, I cannot print 8 pages right now. No way. I'm looking at the decline of the paper stash.
I had my wife go up to, she coaches and teaches AP Bio at the same school I do, and Verge knows that. But I went ahead when she was going up to the field house to get for her last run of things she could get, and she did grab me 2 reams of paper. So if anyone from my school district's watching, I owe you 2 reams of paper. But
you're in better shape than I am.
Yeah, so I'm not pressured yet. But in a month, those 1,000 pieces of paper, I may not be quite as cavalier about using them. All right, so These are adapted from AP Classroom. Some of them were free response. Some of them were multiple choice. We've made them all free response. We also have, there were a few we changed them because stems weren't given, or we wanted to make it more aligned with Unit 6 knowledge. Then Unit 8 material took a little bit of the context back and things like that. So as Verge promised, she just did number 8. And I am going to jump all the way to number 14. And there are 2 calculator active ones in here. If we have time, we might come and get to them today. But if not, that'll give you a little practice with your calculator, but nothing super hard, just a definite integral. And if we want, maybe we could use that tomorrow as a review or later in the week. So I need to scoot my Zoom interfaces out of the way. Okay, so this is number 14, and I'm going to take some time to read it to you. And that was fun. I moved the camera and the paper together so that if you saw the background scoot. What is the average value for the portion of the curve y equals 3x minus x squared, which is in quadrant 1 of the coordinate plane? And since I don't have a calculator on here, I am anticipating doing this without one. I know a lot of you would run to Desmos and get a quick sketch or into your calculator, and that's fine. But what type of curve is that, Verge?
Quadratic, so it's going to make a parabola.
Yeah, and I'm looking at quadrant 1.
Can I keep talking?
Oh, absolutely.
I can see that negative x squared, so I know it's opening down. And I'm really concerned about the, oh, good, I'm glad you factored. I'm concerned about the x-intercepts because those are going to be my bounds. So I probably would just do GCF factoring like Mark did, and then, yeah, we don't really care the y value of the vertex, although I guess at the end it might make sense. Yeah, axis.
We care deeply. We're just not going to find it right now.
Yeah, it's just not necessary for this.
So we're trying to find that area under this parabola. So we're going to integrate from 0 to 3. And I'm going to go back to the expanded form. And then again, we're finding average, right? So I'm talking about finding the average value. And my interval is 0 to 3. So I'm going to have to throw 1/3 out front.
Mm-hmm.
And then I'm going to get 3/2 x squared, adding 1 to that unseen exponent of 1 and dividing by 2. And then adding 1 to my 2 and dividing by 3 by multiplying by the reciprocal. And then that 1/3 still out front. So there's my antiderivative. And then again, our fundamental theorem of calculus is I just get to plug in my B and plug in my A. I would normally, obviously at this time in the year, not plug in the 0 unless it's the first time we've done it in a while, and it's the first time we've done it in a while. So
the danger is if you think, as Mark's bringing everything down, if you think plugging in 0 to whatever your function is, your antiderivative, if you think plugging in 0 is always going to yield 0, well, here comes cosine of x, and then that doesn't yield 0 when you substitute in 0. So you have to be pretty confident that when you are not plugging in your 0, that the value there actually is 0. Yes. Yeah, that looks good.
So yeah, and I always, the 0 minus 0 just looks like a face to me. So so we've got 3 cubed is 27, divided by 3 is 9. Here I've got 9 times 3 is 27. You know, AP, this would be fine. You could actually stop here, right? On AP FRQ now.
FRQ meaning free response question. Yeah.
Now, multiple choice in class and college, I probably want to go a little farther. That's 13/2. So this is 4.5 times 1/3, really taking a risk skipping steps here. But it's feeling like 3/2.
Yeah, it is. I already did it this morning.
Yay! Okay.
Give yourself a smiley face.
All right. So, yeah, so when you guys are taking the exam on May 12th, you know, don't run the risk of this. You've got a 25-minute or 15-minute time limit. You probably won't be doing anything this straightforward anyway, but, well, you won't be doing an average value for sure. But in any case, as soon as you have that antiderivative and have plugged in those bounds and you have a numeric solution on an AP FRQ, I would bail, but you're going to have to go farther on a multiple choice or in your college courses. Or if you're doing this in real life, no one wants that as a, yeah, hey boss, this is how much, this is our average value for the month, you know. All right, so.
Next one is 3. Gonna do number 3 next.
Oops, there's the answers, whoa. And I'm just keeping the pages in order because it'll make it easier to hunt later. All right. Find the average value of f on the interval from -4 to 4, closed interval, of f of, and f of x is equal to 16 minus x squared. So once again, we are playing with an average value. How wide's our interval?
8. 4 minus -4 is 8.
So we're going to have a 1/8 out front. And then we're doing the integral from -4 to 4. And I didn't do something here that I tell my students to do most of the time, and I did do on number 14.
I know what it is.
What do you think it is, Rich?
It's graph. You didn't graph it.
I didn't draw a picture.
Yeah, that's not a very familiar graph. Maybe that's
No.
why, I don't know.
Right. So, you know, but if I start trying to integrate this and I start trying to play with a UDU, my DU is -2x. I don't have that there. Some of my friends in IB and BC classes might be going, oh, it's a trig sub. But what? Trig sub, you know, don't know what that is possibly. So how could we possibly find this integral? Well,
yeah.
Go ahead.
Well, actually, he is going to draw a picture now. But, and this is something that I do make my students hopefully recognize. And if you were watching the differential equations lessons last week, you might recognize this as a conic section. Oh, he's doing a little bit of evaluating. Oh, that's cool. Just kind of plugging in X values, getting Y values. Yeah. That's a great idea. Yep. So he's setting square root of, yeah, he's solving for, yeah. So it's a little easier to recognize in its form of x squared plus y squared equals r squared. Yeah.
And it's a semicircle.
Yeah.
And, he said very loudly.
Yeah, AB students have to recognize this square root expression as either the top or bottom half of a semicircle. If the negative's out front, it would be the bottom half. Yeah.
Yeah.
Cool.
And so we have to remember back in Unit 6 sometimes that even when we can't do an indefinite integral for a closed form, or we just haven't covered it yet, we can use geometric formulas to evaluate these definite integrals. And so looks like my radius is 4.
Mm-hmm.
So that's my definite integral.
Mm-hmm.
Still got that 1/8 out front. And coincidences of coincidences.
It's so
pew,
pretty.
Pew.
Yeah.
My average value for this is pi.
Mm-hmm.
So right here about 3.14159.
Ooh, I'm so glad you just sketched that. That's exactly what I was imagining in my head. Mm-hmm.
How cool is that?
Very cool.
And quarter circles, semicircles are fair game on the exam for you guys. And just be aware.
Yeah. Excellent.
Right,
what number is next? 9. Number 9. Okay, number 9.
Number 9. Ooh, all righty. I'm not sketching this one.
Although with your idea of plugging in, you know, the 0 and the 2, but no, you're
0,
right.
Yeah, definitely has a goes through the origin. I can tell that, and
but
also goes through 12, 212. 8 plus 1 is 9. Yeah, so actually could get I could put a dot at 0, 0 and a dot at 12, and know my answer should be between those. So 0, 2 x squared. The square root of x cubed plus 1 with respect to x. I'm going to probably stop doing this in 2 colors after this problem, but again, our average value from 0 to 2. And I do this probably a lot faster in my class than in some others, but we will go ahead and do a U to U. I do this as a chain rule. I'll kind of show how I do that in a second.
Yeah,
And actually, I'm gonna.
because last week I showed you substitution with different. I've done it slightly differently. So.
Yeah. So I've got my U to the 1/2. And then I am going to take advantage of all these wonderful pens Verge sent me.
Thank
So
you.
du is 3x squared plus 0, right?
Mm-hmm.
And that means, oh, no, it's not. It's 3x squared dx.
Yeah, you need the dx there. I usually write du dx is equal to that, but the way you do
Yeah,
it is
and
good
I
too.
use the differential definition, which is the du is the derivative times dx.
Uh-huh.
Tomato, tomato. Because nobody says tomato. So x squared is going to be, we could do this lots of ways. I'm going to do it kind of bizarrely. And that dx is still there. And then when x is 0, u is 1.
He's changing his limits of integration. This is what students tend to resist, but in the long run, if you do this, your habits are much tighter.
And I love the u to u lesson. I'm going to go ahead and use my puns. If it's an indefinite integral, you don't have to worry about these bounds, but you're indefinite and you have to go back to your x at the end. This one, I know my bounds. I'm definite. I am never going back to my x. I have made this problem all about you. So I love that lesson. It's even more delicious if I have a couple former couples in the room.
Former couples, right? Ones who are no longer,
Yes.
but they're still having to sit through class together.
Yes, and giving side eye to each other while I do this lesson. Okay, hey, u to the 1/2. Verge, you did this.
Yeah, it's going to be 2/3 u to the 3/2.
Awesome. That saved us a little time and legwork. Mm-hmm. And if I plug in 9, let's see, I'm not going to skip that. I am going to go to one color though.
So 9 to the 3/2 minus 1 to the 3/2.
And again, you can't just dismiss that second bound because it's not 0, right? But the square root of 9 is 3. 3 cubed is 27. 27 minus 1, feeling like a 26 times 2/3 times a 1/6. Oh God, there's all kinds of stuff going on. But 52 over 18 or 26 over 9.
Yep, that's right.
It is right? Yay.
It is right. Yep.
Call me butter. I'm on a roll.
Woo-hoo!
All right.
He like, let me tell you how they say that in Mississippi. He like butter, he on a roll.
We have 7 minutes left. You think we have time for 2 of these? I've got a little
definitely.
clock.
Let's do number 1 for sure.
Okay.
Because it's just, I love problems like number 1 because
number 1's also one like, that if you like it, there's a net, and I need to scoot that down. My picture's up there. Sorry, I should let you finish, but
well,
I was just gonna go.
Like it because it seems like there's not enough information. Like we don't have an explicit function or a graph or anything. And so how can I do this problem? And Mark, you go ahead and say, I think you were saying there's one very similar to it.
Yeah, this is a nice one because if you do your work tonight and you work through some of these, there is a similar question in the packet. So the average value of function. So what I'm gonna do is again, this is math, right? And I always tell my kids, when I picture calculus, I picture the ballroom in Beauty and the Beast, and there's the geometry staircase and the algebra staircase, and they needed a landing, and then there's all these other staircases that go off into math, and that landing is calculus. So what we did the very first day on March 25th is read an equation out of a sentence. The average value of this function. So get integral of -1 to 2 of f of x dx, and we're going to divide it by 2 minus -1 is equal to -4. That
so
is
he's translating from English into math, and it's it's amazing how tight math is once you do that. Now you can really start manipulating
And
things.
so, and I'm not going to play with it much beyond that yet, because let's see what we get from this other information. So now I have the average value from 2 to 7. And I am going to go ahead and do 7 minus 2 is 5. Of f of x dx is 8. So I have these two integrals, and now they want this last one. I always click the eraser, it doesn't work. Average value from -1 to 7 of 1/8. And I need this integral from -1 to 7, but that's going to be these added together, those two integrals. I don't quite have those integrals yet. So horrible organization.
This is actually properties of definite integrals.
Yeah, so if I multiply by 3 to both sides, that integral is going to be -12. And the integral from 2 to 7 of f of x dx is going to be 40.
Mm-hmm.
So what's going to be the integral from -1 to 7?
Well, the integral from -1 to 2 plus the integral from 2 to 7. So that would be -12 plus 40 or 28. Yes?
Yeah, I think so.
Okay.
7/2.
So
7/2. I got it right.
Push it up a little bit.
Sorry.
Yeah. Okay. So there's your -12 plus 40. Yeah, good. I can see all that.
Sorry. So there's my purple.
Uh-huh.
And there's my red, and that's my integral divided by 8.
Uh-huh.
So pretty nifty.
Yeah, that one's really nice. We do have about 3 more minutes. Do you want to wrap it up, or do you want to talk about like kind of point them to number 6 and then tell them we're going to pick up with that?
Yeah, let's just talk about number 6 to get you started on it, because it is a really neat problem, very rich. Would be one that would probably be hard to throw into a search engine. So as we start thinking about things that may be on the exam.
And also ties in beautifully to what we did last week with differential equations. Yes. So this has really got a lot going on with it.
So let f be the function that is defined for all real numbers x and that has the following properties. Property 1, or I, the second derivative of x is 24x minus 18. The first derivative at 1 is equal to -6. And the function at x equals 2 is equal to 0. And then find the average value of f of x on the interval from 1 to 3. So we need that. So this is the new stuff today, but everything else here is old material. So given the second derivative, how can I get all the way to that function? What do you think, Verge?
Anti-differentiate. Don't forget your C.
Yeah. So we can do an indefinite, right? We can just do antiderivative.
I mean, this to me, and again, I look at stuff with a lot of years of experience, and I look at this and I think that's got to be polynomial, because who has a second derivative of 24x minus 18? It's got to be some sort of polynomial. So in fact, when you anti-differentiate 24x minus 18, you get 12x squared minus 18x plus c, and then using that f prime of 1 equals -6, that'll help you to get the c value.
And I'm going to end it there, because then it's wash and repeat, because once you have f prime.
Wash and repeat. Yeah. I've never heard that before. Yeah, that's awesome.
Just rinse it out and then integrate again to find f of x. And
that's excellent. Yeah.
All right. So I think that almost wraps up our time for today. Let's go back to our slideshow. I'm just going to leave this here for you to pause it if you need it. Again, anyone needs connectivity or mobile tools, please direct them to cba.org/tech. Dropbox is active. It has these 2 documents in it. Again, if you want to save some paper or just look at it digitally, there's the paper saver version, or if you have paper and the luxury of some space to write in, you can print out the version like I did. So.
Yeah, and don't forget about running out of printer ink too, because my printer ink is low, so it's not just about the paper.
And just again, the exam information, we'll leave that up for the remainder of our time as we sit staring for our out from our captain, my captain off screen.
Yeah, thanks for joining us today, everybody, either live or after the fact. We really appreciate you. If you have any questions or concerns, you should direct them to your teacher. If you're a teacher, you should probably try and find us and ask your question. We're not hard to find. I've actually had lovely connections with students who found out my email. They're very clever and have sent me some nice emails. And I know, Mark Corrali, you've had some from students as well. And I'm talking about not my own students.
No. And I don't know if Meme Monday is going to be a thing, but thank you to our producer who suggested this background today. And at least stay through the videos till I change the background. I'm going to try and produce 28 different ones over these weeks.
I'm very confident you can do it, Mark.
All right. Bye, everybody.
Bye.